Today we are going to discuss regarding the circuit theory. So main components of the circuit theory is the resistor. So how will you calculate the equivalent resistance of two resistors or three resistors when they are connected in series or parallel? Let us considering two resistors R1 and R2. Let us consider one resistor is R1, one resistor is the R1, and another resistor is known as R2. When the two resistors R1 or R2 connected in series, so the equivalent resistance, that is R equivalent will be the R1 plus R2. R1 plus R2. And if we connect these two resistors connected in parallel, so what will be the resistance? R equivalent. That means if the two resistors R1 and R2 connected in parallel, so what will be the equivalent resistors? So if the R1 and R2 connected in series, so what will be the equivalent resistance? R1 plus R2. So R equivalent equals to R1 plus R2. But what is the connection of the series? What is the connection of the series? What is the series connection? So this is R1 and this is the R2 connection. This is R1 connection and this is R1 connection. So if we consider the A and B is the two endpoints of R1. So R2 will be the one point of the R2 connected to the B and another point will be the open. So that is given by C. So now the equivalent resistance of R1, R2 will be the R, A and C. A and C. That means the terminal of A and terminal of C. So resistors between the terminal A and terminal C will be the R equivalent. And the calculated value is the simple addition operation R1 plus R2. So end point of the R1 is connected to the starting point of R2. That is the series combination or series connection. So starting point of R1 is the A and ending point of R1 is B. Starting point of R2 is the B and ending point of R2 is the C. So what is the series connection actually? Now end point of the one resistor is connected to the starting point of the another resistor and so on. If we connected the R3, so what will be the value? The end point of R2 is connected to the starting point of R3. In this way, so serial fashion, the connection is the serial fashion. So that means if the current passing through the resistor R1 will be the same as the resistor R2. If we connected the 3 resistors or 4 resistors or 5 resistors, so all the current passing through the R1 will be the same as the R2 as well as the same as the R3 as well as the same as the R4 and so on. So current passing through the resistors will be the same is defined by the series connection. So in all the resistors are connected in the series, the current value of the resistors are same. So this is a series connection. So now let us discuss the parallel connection. So what is the parallel connection? So R1 value this and R2 value this. These two resistors are connected and joined together So and this terminal is known as the A and this terminal is known as a B. So this is R1 resistance and this is R2 resistance. Two resistors are connected in series, so current will be the same all the cases. Current will be the same all the cases. But in case of parallel combination, all the resistors are connected one point, that is the starting point, and ending points of the other resistors at the same point. When these connections are taken together, the combination is known as the parallel combination. So in case of parallel combination, current will be divided between their resistor values. If the two resistors R1 and R2 are connected in parallel combination, so current will be divided at the terminal point, that is the A point. The current passing through the A point and divided through the R1 as well as R2 depending on the resistor R1 and R2. So now we will calculate first what will be the equivalent resistors of R1 and R2. What is the equivalent resistance of R1 and R2? So here if we define it RAB, that is the parallel combination of the two resistors R1 and R2, is RAB is the R equivalent. So it is defined by R1 into R2 by R1 plus R2. R1 plus R2. So this is the value. So that means in the series combinations, the current will be the same through all the resistors, but in case of parallel combinations, current will be more if the resistance value is the less. If the current value is the less, if the resistance value is the more. So it is the reciprocal of the current passing through the resistors. Reciprocal means if the resistance value is more and current passing through the resistor value will be the less. So this is the equivalent values of the R1 and R2. If we are considering the two resistors R1 equals to 10 ohms and R2 equals to, for example, 20 ohms. So what will be the series resistance of R1 and R2? So series resistance R equivalent series REQS if we consider, so it will be simple addition value 10 plus 20, that means equals to 30. That means it is a 30 ohms. If 10 ohms, if it is R1 equals to 10 ohms and R2 equals to 20 ohms, so total R equivalent in series RQS, S for series, if we define. So what will be the parallel combination? So R equi P, that means parallel combination. So numerator is the product form, that means 10 into 20, and denominator will be the 10 plus 20. That means 10 into 20 by 30. So that means 20 by 3. That is the 6.66 ohms approximately. Approximately 6.66. So this is the actual two resistors. First one is the R1 and R2 resistors. R1 and R2, two resistors are considered here. So equivalent resistance is the additive sum. That means the R1 plus R2. So the connection is in this way. A, B and C. So end point of the R1 is connected to the starting point of R2 in this way, the series fashion. So that means current is passing through the R1 is same as the R2. In series combination, current is same in all the cases. So RAC means the A terminal and C terminal, resistor between A terminal and C terminal is the RAC equals to R equivalent equals to R1 plus R2. If both R1 and R2 connected in parallel in this way, that means starting point of R1 and starting point of R2 are connected at a one point, and ending point of R1 and ending point of R2 connected at the point. In this way, if we connect the known as the parallel connection. So parallel connection, total equivalent resistance will be RAB. So RAB equals to R equivalent equals to R1 into R2 by R1 plus R2. In the numerator is the product form and denominator is the additive form. So here case 1, R1 equals to 10 ohms, R2 equals to 20 ohms. So series combination will be the additive, that means that 30 ohms, and R equivalent P, R equivalent P means parallel combination 10 into 20 by 10 plus 20, that means 6.66 ohms. So in case of series resistance, if the resistor value is greater than 1, in series combination the value will be the more, and in parallel combination and the value will be the less in each cases, in all the combinations R1 and R2, if R1 and R2 both are greater than 1. So now considering another example, 3 resistors R1, R2, R3. If the 3 resistors connected in series, so this is R1, end point of R1 here, and starting point of R2 here, so this is the R2, and an ending point of R2 here, so it is connected here, R3. So R equivalent in series means S is the R1 plus R2 plus R3. So if R1 equals to 10 ohms, R2 equals to 20 ohms, and R3 equals to 30 ohms. So R equivalent will be, equivalent series will be 10 plus 20 plus 30. So that means 60 ohms. So additive value is the more in case of series. And if the three resistances R1, R2 are connected in parallel, so what will be the combination? This is the combination. This is the combination. One is R1, R2 and R3. This one is R1. This one is R2. This one is R3. So connection, all the starting point connected at the same point, and the end points of the 3 resistors at the one point. So if we consider here A and this terminal is known as the B, so R equivalent parallel, P for parallel, will be the R1 into R2 into R3 by R1 R2 plus R2 R3 plus R3 R1. So here equivalent resistance will be 10 multiplied 20 multiplied 30 divided by 10 into 20 plus 20 into 30 plus 30 into 10. That means 10 into 20 into 30 by 200 plus 600 plus 300. So that will be the so what is the value? 10 into 20 into 30 divided by 800 plus 300, 1100. So cut these two values. So what is the value? 60 by 11. 60 by 11 is ohms. 5.4 ohms approximately. 5.4 ohms approximately.